All right, let's get started. Welcome everyone to the July Water Conditions Monitoring Committee meeting. My name is Emily Adrid, and I'm the Water and Climate Specialist at CWCB. Today, we just have a normally scheduled meeting. We'll have presentations from the Colorado Climate Center and NRCS. So, Peter, I believe you're up for the Colorado Climate Center.
That's correct.
Awesome.
Okay, can you see my PowerPoint?
Yes.
Excellent. Thank you so much for having me on this morning. For those who may not know me, my name is Peter Goebel. I work with the Colorado Climate Center at Colorado State University. And today I'm going to be giving our regular climate conditions update, as well as a little look at the seasonal outlook and what we might expect as summer transitions into fall. This poorly resolved picture is from my in-laws' place this weekend. We had some ping pong ball sized hail, and it was an interesting storm. It was about half of the moisture that we've had for May through July so far, and it was less than an inch of moisture, at least if the rain gauge is to be believed, which in these situations they do tend to undercatch, but it was some of our only really good thunderstorm activity of the season so far. Okay, so our typical agenda is we're going to start with the seasonal climate conditions update. I'll take a look at the U.S. Drought Monitor, what's changed on it and why. And then, like I said, we'll get into our seasonal forecast information. Okay, we're going to start with this quadrant chart where we are looking at accumulated precip on the horizontal axis and average temperature on the vertical axis. The cross hatches show the normal conditions for 1991 through 2020. And so the star shows what we have for April through June, or the last 3 full months. We'll get into what we've gotten for July in just a couple slides here, but this shows April through June 2024 with the star. So statewide, we're a few tenths of an inch below normal in terms of moisture over that time frame, and a little bit above average in terms of temperature. Looks like I think I have on another slide that it's 1.5 degrees statewide above average for the last 3 months. June was well above average. April and May were closer to or even a little bit below those 91 through 2020 normals. So that's why you don't see this mark even higher. Okay, so like I said, June was well above normal. Here is the graphic to show that. So this is the statewide temperature rankings using data from the National Centers for Environmental Information. And these data go back to 1895. So this is ranking things as compared to the last 130 years of record. And we see there are a couple patches where we actually had a record warm June, including in the San Luis Valley, as well as right around the Denver metro area. Some of you can probably attest to that. It was a very hot June, and then a couple patches out on the Eastern Plains as well. But perhaps more importantly, just nearly across the entire state, this was one of the 10 warmest Junes on record. I think it was the third warmest overall. We've got that right here. And it was 5.5 degrees above the 20th century average and 3.7 degrees Fahrenheit above that 1991 through 2020 normal. Okay, here we're looking at a time series of June temperatures. So this is average statewide using that same National Centers for Environmental Information data set going back to 1895 and then all the way forward through 2024. And we can see our long-term or our 20th century average is 61.2, whereas we were at, I believe it was 66.7 for 2024. So again, well above our longer term and nearer term averages. And then you can see the 2 Junes that stand out above this one are 2002 and 2012. So no big surprises there with the Junes that are still above this mark. Okay, here's a look at temperature rankings for the last 3 months. So I showed this quadrant chart earlier. I think I said 1.5. It's actually 1.4 degrees above the 1991 through 2020 normal and 2.8 degrees above the 20th century average statewide for the last 3 months. And you can see there are areas of the northern and central portions of the state that were a little bit cooler with respect to historical rankings, whereas the eastern third of the state, for the most part, is in the top 10 for the last 3 months. These areas that were a little cooler, there was some cooler air the end of April through the middle of May that really affected especially northwest Colorado. And so that really still shows up on this last 3 months. And then here is the time series. Again, instead of just for June, this is for the last 3 months. And you see how when we include the influence of April and May, much closer to the at least recent 1991 through 2020 normal. Okay, this is looking at the last 12 months. So this is July of 2023 through June of 2024. 1.5 above average or above the 1991 through 2020 normal. That's quite significant when we're looking at when we're looking at a full year of data rather than just 1 month of data. And you can see for most of the state, it's in the top 10 statewide, fifth warmest July through June on record. And this is what has happened since the beginning of July. This map is probably a little bit surprising looking because we did have a pretty impactful heat wave the second into third week of July here. But with the more moderate temps recently, as well as some cooler temperatures in the first week of July, we're still looking at temperatures largely across the state a little bit below the 91 through 2020 normal. So this color map is with respect to that recent normal, not the 20th century average. And we see that for the most part, July, a little bit below or right around normal, but there was certainly some heat in there. And that's what I wanted to show with this graphic. So here we're looking at the average highest all-time 4-day average temperatures by climate region across the state. I don't know how many of these graphics that we've shown at WCMC with these 11 regions, they were drawn using a clustering analysis done by Russ Schumacher at the state climate office. And the regions are drawn basically based on where annual kind of seasonal weather variability patterns are similar. And so you see groups like the Northern Front Range together, as well as places like the Eastern Plains and the Arkansas, kind of the a lot of the Arkansas Basin. But anyway, for the middle of the state and kind of eastern side of the Continental Divide, this heat wave near the middle of July was at least within the top 15 for all-time 4-day average temperatures. And we can see these rankings for these regions on this graphic here. So statewide, it was the 14th highest. And then if we look at the Pikes Peak region, kind of in the center of the state, Colorado Springs would be a part of this, 4th highest all time. And then Northern Front Range, we're looking at 7th highest all time. One thing I'll say about this heat wave, it could have potentially been even a little bit higher up on the rankings list if the low temperatures were a little bit higher. So we did see high temperatures that at least threatened some of our all-time high temperature records. So at the Fort Collins weather station, we got up to 102 degrees on July 12th, and that was only 1 degree off of our record mark from July of 2005. And this graphic kind of illustrates that. So here we're looking at, in the upper left, Denver Central, or sorry, DIA, and in the lower right, Grand Junction at Walker Field. And the blue bars are showing the temperature highs and lows for each day going back to October 1st through just a couple days ago in July. And then the red line here at the top of each graphic is showing the record high for each day. And so you can see during that heat wave, we were right around or setting new records at DIA. Not quite as severe with respect to the historical record out west, but still well above normal. Okay, now shifting gears to precipitation. This is a look at June 2024 with respect to that entire historical distribution. We had a really nice surge of moisture in the fourth week of June out in the southwest portion of the state, including the San Juans and San Luis Valley. And so June ended up being a top 10 wet June on record for southwestern Colorado. That might not mean as much as you might think, because June is the driest month of the year for a lot of southwestern Colorado. So it doesn't take as much to have a wetter than normal June as it does other times of year. Conversely, on kind of the northern Front Range and areas just immediately to the east out on the plains, such as, Weld, Adams, Arapahoe County into Denver County, we saw one of the driest Junes on record, and June is part of the wet season here. So much more significant to see dry conditions there. And then if we average things statewide, because of the amount of western Colorado that was above average, we're a little bit above our historical kind of 20th century average for June. And we can see, looking at this time series, if anything, the more recent average is a little bit drier, I would hazard a guess. I didn't do that computation because things are not changing in one direction with precipitation the way they are with temperature. So the 91 through 2020 average is much closer to this longer term average when we look at precipitation, but a little bit above that longer term average for June. Let's see, if we back out to the last 3 months, we can see that there are some areas of the San Luis Valley and southwestern Colorado that have been wetter than the long-term average, whereas there are, again, areas of the northern Front Range and immediately to the east that have been drier. We see that large parts of Larimer County and northern Weld County are within the top 10 driest over the April through June period. During May, May is typically the wettest month of the year for this part of the state in the northern Front Range, but we missed out on a lot of moisture in May, whereas May was much wetter than normal in the San Luis Valley. And then again, this is just backing out for the last 3 months, so April through June, just a little bit on the lower side of that statewide longer term mean. Okay, and then this is the last 12 months. For a long time, these 12-month graphics were showing a large area in eastern Colorado that was much wetter than normal, because May through July of last year were so much wetter than normal in some places in the eastern part of the state, including that Adams Arapahoe County area I was just mentioning. May through July of 2023 was the wettest 3 consecutive months in this whole data record going back to the 1890s. But that's now out of our, or at least 2/3 of it is out of our 12-month rankings here. And we see a lot of the state is near normal or a little bit below. In some cases, such as out east near Kiowa County, that area, it's been a bit of a roller coaster. But yeah, a lot of the state right in that normal range between the 35th driest and 35th wettest in the historical distribution. Okay, now we'll take a look at the US Drought Monitor and discuss some of the changes that have been made. I'll pause just for a brief moment here. Any questions so far? Okay, we'll keep plugging along with the drought update. So here is the current US Drought Monitor depiction in Colorado. And most of basically all of this drought in the Northern Front Range, urban corridor, and plains immediately to the east. That's basically all new as of the last couple of months, which how much drier than normal our typical wet season has been. That April through July timeframe is where we get a lot of our moisture on the eastern foothills and out onto the urban corridor and out onto the plains. And this area, for the most part, has missed it in 2024. So a lot of this D1, D2 is new on the US Drought Monitor. I believe the Boulder Cooperative Observer Network station would need over another inch, about an inch and a quarter of moisture by the end of July in order to not have their driest May through July on record. And looking at the forecast, which we'll get into more later, it's not looking likely. So that's a long historical record, very reliable station, and it's likely to be the driest on record over that time period. I do suspect that we'll likely see some improvements across southeastern Colorado on the next iteration of the US Drought Monitor, because they had some really good rain over the weekend, kind of that same time frame when the hailstorm hit the house west of Berthoud that I was showing a little bit earlier on my title slide. Okay, these are the changes over the last 12 weeks. So like I said, all of this drought over Northern Front Range, urban corridor is new because we had wet conditions in 2023. And although winter was mild, winter did bring reasonable moisture as well as the early part of spring. But as we turn the corner into summer, it's certainly been hot and dry. Now, when we look at southwestern Colorado, things have tracked the opposite way on the US Drought Monitor. As I was showing with the precipitation slides earlier, we did see an unusual amount of moisture in June. And we've also seen a number of areas across western Colorado where the stream flows during the peak flow portion of the year were a bit higher than maybe was expected. I guess I'll let NRCS get into that. But I was talking with Paul Miller of CBRFC last week, and in some areas in Colorado, they feel like they didn't quite capture just how much snow there was. And certainly the fact that we had some of that beneficial snow into late April and the first half of May helped with conditions out there. So this is changes over the last 52 weeks, or basically 1 year. And we see all of the drought on the east side of the Continental Divide. That wasn't there a year ago at this time. Whereas we did have a little bit more drought, or at least abnormally dry conditions shown on the US Drought Monitor in southwestern Colorado this time a year ago. Here's how soil moisture conditions are looking across the state, at least as of a few days ago, from the 1 kilometer resolution Western Land Data Assimilation Systems model. We can see quite a bit of area in the northeast quadrant of Colorado, where we are seeing below normal soil moisture, really up and down the I-25 corridor, all the way to nearly the New Mexico state line, and certainly up to the Wyoming state line. But then out across the eastern plains in the South Platte River Valley as well, we're seeing these below normal soil moisture conditions, at least according to this model. Whenever I show soil moisture model conditions, it's important to keep in mind that these models are by no means gospel truth and oftentimes disagree with one another. But I think that given the temperature and precipitation signal that we've seen in recent weeks, it's not shocking to see this soil moisture signal. Maybe the Greeley area is a bit shocking. A couple things there. This soil moisture model, I think, sometimes shows some funky output over urban areas. You can really see that with the hole punches in the metro areas of Colorado Springs and Denver. But also it's worth keeping in mind that Greeley did have an isolated but quite strong thunderstorm dropping nearly 4 inches of rain. I believe that was near the end of May, but I'd have to double check on that. All right, that's it for the drought update. I'll go ahead and dive into our, that should say summer fall outlook. It looks like that slide didn't get updated, but these slides are correct. So this is showing our 7-day forecast, and you can see the timestamp in the upper right-hand corner. These slides have been updated where we're looking at the July 22nd through July 29th. And we can see that it looks like the next week anyway, according to our numerical weather prediction models, is looking drier than normal across most of the state and certainly out onto the Great Plains. It does look like the San Juans could receive a little bit of moisture coming up from the Gulf and from the Eastern Pacific. There's a bit of a corridor of monsoonal moisture, but you can see that a lot of it is getting pushed further to the west, where we're talking about northwest Arizona, western Utah, all the way up into Nevada. It does look like there's going to be at least a weak cold front pushing across Colorado this weekend, but it doesn't look like much of this moisture will get wrapped up into it. So we could see a little bit of precipitation over that time frame, but it's not looking like it's going to drench us. I know that Kevin Houck on the call, he's often got a little bit of a raised heart rate during this time of year because late July, early August is peak flash flood season in Colorado. And anytime we get a good surge of moisture, there's potential for some pretty high rainfall rates. And, you know, for over the next week, worth keeping an eye on the San Juans. I guess never really take your eye off the ball this time of year, but right now the forecast over the next 7 days looking a little drier. This is the 8 to 14 day outlook, and of course our numerical weather models start to lose a little skill over this time frame, but we are looking at likely an upper level high pressure ridge setting back in over the end of July, first week of August, and so we see an increased probability of above normal temperatures across Colorado, and a slight tilt towards below normal moisture. I think, if anything, based on what I'm seeing in the models right now, this tilt towards below normal moisture might be underdone. I think that based on what we're seeing now, we could maybe even extend this contour, some of the stronger contours, like the 40 to 50% chance of lower terrestrial moisture out over Colorado, because right now things are looking drier than normal over that week. We'll see how things evolve. Like I mentioned, at the 8 to 14 day time scale, it's things are a little bit less certain than in that 0 to 7 day window. Okay, so when we get beyond 8 to 14 days, our numerical weather prediction models descend into chaos, and we have to rely on slower moving parts of the climate system and statistical relationships between what happens with things like sea surface temperature patterns or land surface temperature and soil moisture patterns, and how those influence weather on seasonal timescales. And right now, we are seeing that La Nina is starting to begin to develop in the Eastern Pacific off the coast of South America there. But it's not officially a La Nina yet, but it looks likely that La Nina will develop. And that does have an influence on our weather here in Colorado. So this is a plot looking at the correlation between El Nino versus La Nina and moisture in Colorado, and it's chunked up by season. So we've got December, January, February in the upper left, March, April, May, upper right, June, July, August, lower left, and September, October, November, lower right. Areas that are blue are areas where La Nina tends to be wetter. Areas that are red are where El Nino tends to be wetter or La Nina tends to be drier. So we're going into this late summer, early fall season. So if you look at the bottom two graphics, you can see that with La Nina developing, that's generally not good news for moisture in Colorado. If it hangs around through the winter, it could be good for our northern Rockies, but it's often, or more often than not, associated with warmer and drier than normal fall conditions. And that looks to be where we're headed. So this is the probabilistic forecast for La Nina, neutral, or El Nino conditions. Right now, we're in this June, July, August time period, and we have neutral conditions. La Nina is expected to develop, at least an 80% chance that it's here by October, November, December. and it's likely to last through the winter and early spring as it often does. But there is a chance that we get stuck in these neutral conditions. I guess the thing that we can say with a little bit more certainty is we're headed for a not Nino, where we're looking at under a 5% chance over the coming seasons of El Nino conditions. So likely La Nina development, but we could end up stuck in neutral territory. So we'll see what happens. And with that in mind, these are the seasonal outlooks for August, September, October over the coming months. So across Colorado, especially Western Colorado, we're seeing an increased probability of above normal temperatures. And then again, across the entire state, an increased probability of below normal moisture. And it's not just because La Nina is developing that we're seeing this. That is certainly an important factor, especially when it comes to the precipitation. But with temperature, it's also keeping in mind that we do have a warming trend. So the Climate Prediction Center does rely on that warming trend to gain a little bit of skill over equal chances, especially in the late summer and early fall when interannual variability is at its lowest. Or another way of saying that is if the climate wasn't changing, if the climate wasn't warming, then we would see the kind of least difference from year to year in temperatures in kind of the July through September time frame. Whereas in winter, when we get these massive cold fronts, temperatures can be all over the map. And so because the interannual variability is greater, you can't gain as much skill just from banking on the trend. But we're in the time of year where you tend to be able to bank some skill from banking on the trend. La Nina, again, a factor, but then also a number of the models that try to simulate the dynamics of the North American monsoon are still showing a weaker monsoon year. And that does seem to be what's bearing out, at least right now. Well, of course, we did see that fourth week of June, we had some good moisture in southwestern Colorado. But right now, that's also a factor. And then I saw in the Climate Prediction Center discussion of the seasonal forecast that they mentioned dry soil moisture as well, where if you have dry soils over a large enough region, that limits what evaporates into your atmosphere and can limit precipitation rates. For our region, that tends to be a pretty weak signal because most of our region, most of our moisture, regardless of season, does come from somewhere else, a lot of it coming from the ocean. This time of year, it can even come from places like the humid Midwest. And then this is just the same thing, but looking one lead further out. So this is September, October, November. And we still see this below normal moisture signal is here, but you're starting to see more of the calling cards of La Nina coming into place with above average precipitation forecasted for the northwest and northeast corners of the United States. And then you really see the La Nina signal come in when you look at October, November, December. Once we get into winter, things look a little bit better for our mountains. So if La Nina holds on, hopefully this will start to look a little bit less grim. And then just the fire weather outlook for the next month. I was a little bit surprised that it does not yet show above normal potential for significant wildland fires in Western Colorado. I guess it is worth keeping in mind that we had a decent snowpack year and that June for a lot of southwestern Colorado was above average for moisture. So just in the southeast quadrant of the state is where they're showing things elevated, at least for now. So we'll see kind of what hangs on there. A couple takeaways to go home with. Summer has been warmer than normal so far. We experienced a top 10 heat wave in the historical record for much of the state last week. It was 14th for the state averaged over the entire area. Moisture in recent months has been mixed, unlike 2023. Certainly, the north central portion of the state, Northern Front Range, urban corridor, has been much drier than normal, but we have seen some decent moisture to the west, areas like southwestern Colorado, so kind of mixed across the state. When we look at the seasonal forecast, things still tilted towards above normal temperatures, below normal moisture. And some of the reasons for that include a shift to La Nina, climate change, some of our dynamical models predicting a weaker monsoon, and then to a lesser extent, dry soil moisture. And then fire season, relatively benign across the state so far, knock on wood, but there's an increased probability of above normal wildfire activity for the second half of summer in some areas across the state, like southeastern Colorado. We'll see what happens with this drier and warmer than normal seasonal forecast. Last time I gave a talk at WATF, conditions were still, or sorry, WCMC now, conditions were still pretty good, but the seasonal forecast models were starting to show these hotter, drier than normal conditions. And I think if I were to show a verification from the last time we showed that I was on showing a seasonal forecast, it would probably look pretty accurate, at least this year. All right, so that's going to do it for me. If there's any questions, comments, I'd be more than happy to field those. If not, we can keep this this meeting rolling along.
Fantastic. Thank you, Peter. I think there was a question in the chat. Nick Harris asked why the time frame 1991 to 2020 is considered normal. Thank you, Nathan, for putting that NOAA link in the chat. But I didn't know if Peter, you wanted to elaborate on that at all.
Yeah, that's a really good question. So typically the last 3 full decades have been used by climatologists to establish a normal. The idea there is that if you go too far back, you're integrating things into your normal that may not be representative of the current climate. But if you don't go far back enough, then you're not getting a good enough sample of interannual variability. A couple other points on that. I think with the access to data that we have these days, there's no reason that we couldn't update that climatology every year rather than every decade. Some people might disagree with that because there's always, with these data sets, a little bit of extra cleaning that gets done before submitting the official normals for a 3-decade period like 91 through 2020. But there's also discussion with, especially with temperatures rising, as to whether or not 30 years is really the best time frame to show. And there's definitely a, I would say valid school of thought that with temperatures rising the way they are, at least for temperature, maybe you should only show the last 10 years or the last, perhaps even with some projection as to what you expect normal to be 10 years out. But with precipitation, I would say we need a longer record because precipitation can be so variable from year to year in Colorado and even decade to decade, where we see things like the 1980s and 1990s as full decades were well warmer than the long-term average in Colorado. And similarly, the aughts and 2010s were well drier than the long-term average in Colorado. And the climate models don't necessarily anticipate that it's going to continue to dry the way it's going to continue to warm.
Thanks, Peter. Seems like there's some debate out there on that question.
Yeah, a little bit.
Yeah. Any other questions for Peter?
All right, thanks again.
All right, next up we have Brian. You ready to go?
I sure am. Good morning, Emily.
Awesome.
Good morning,
Morning.
everyone. Yeah, let me see, share my screen here. And go into presenter mode and switch them up. All right, can you see my opening slide there?
Yes, I can.
Perfect. All right. So yeah, again, good morning, everybody. For those of you who don't know me, I'm Brian DeMoncos, hydrologist with the USDA NRCS Colorado Snow Survey Program, and I'll be providing the presentation regarding snowpack and the stream flows, a few other bits of information, reservoir and whatnot, data that we collect and collate from across the state and the country. So recapping real quick, the snowpack that we had this year, snowpack peaked out at about 98% of median across the entire state. That peak occurred in the middle to latter part of April, with a few basins seeing some peaks in early May. And this map is just a look at the individual sites where their snowpack peaked for their respective times. Looking at the time series graph of snowpack over the course of the year, as in terms of the statewide total snowpack, here again is that 98% of normal value here just below the median peak, that green X. And again, you know, Colorado is quite a diverse state, even within its mountains. The southern and western basins typically peak a little bit earlier than those basins in the north and the east. Or just in the north, I should say. And so those northern basins peaked a little bit later here. I think one was in May, early May, and the rest were back here. And I'll show that here on the next slide. When and how much each of those basins peaked at. So again, statewide, 98% of normal. And then you can see some of the individual basins. The Arkansas peaked at 105. And we did have the South Platte peak at May 13th. All the rest were in April. And so, you know, Peter, you bring up a good point. I did provide a number of slides here coming up in this presentation about stream flows, where they peaked at, and the fact that they were potentially a little bit higher than what snowpack may have indicated. However, I think there might be some timing and concentration in terms of how quick things melted out. So I'll get into that here in a little bit. But so anyway, snowpack is old news at this point. The snowpack has passed, and now we're looking at what additional precip we have received since the snowpack has melted out, and how that precipitation is assisting the hydrograph and adding more toward the runoff that we saw from snowpack. So as of yesterday morning, and then actually it winds up being the same today, statewide precipitation is 101% of normal. So both today and yesterday, that value was 101% of median. We had a little bit of precip yesterday that helped boost us, but for all intents and purposes, 101% of normal is pretty much right at normal. And you can see the breakdown here of some of the individual basins. The Arkansas, Gunnison, Colorado Headwaters, and combined Yampa White are all slightly above normal, whereas a number of the other basins are just slightly below normal, as much as 5%. For the year-to-date, the water year precipitation, and don't forget the water year-to-date starts on October 1st and goes through the current day. In this case, I'm not sure why I ended this on the 21st, forgive me. But it is still relatively close, or it's almost exactly where we're at today. So some of these values may be slightly different if you were to look at these values today. Oh, and I'll also mention that if you are looking at information in the San Juan range this week, some of those numbers may go a little bit haywire. We actually have our staff, our crews working in that area right now, and as they perform their calibrations and checks, some of the data needs to be augmented, or it winds up getting changed for a little bit, and then we need to go in there and manually update that information. So I was actually looking at one of those graphs today, the combined San Miguel, Dolores, Animas, San Juan, and there's a in the precipitation, there's a spot where the value goes down. That's because I haven't had a chance to correct that data to this point. So be a little patient while we work through and do our mandatory maintenance. Okay, looking at the last 92 days, or about the last 3 months, the precipitation story is a little bit more varied across the state. The northern half of the state did not receive as much precipitation as the southern half did. As Peter pointed out, June and July are some of the drier months of the year. And so when we receive a decent amount of precipitation, it can make a big difference in the numbers compared to average or compared to median. And so that's what we've seen here. I'll highlight this a little bit more in the next slide as we shorten that time scale even further. But drawing out the simple fact here that we have received a fair amount of precipitation in the southern half of the state, or more specifically the southwestern, which has really helped out a lot. Things were a little bit drier there, and so the precipitation that we've received has helped out a good bit, and I'll show that here in some of these time series graphs. So looking at the last 30 days, going back to June 22nd, I think the bulk of the storms, especially those that hit the southwest mountains down here, started on about June 20th, I believe it was, or June 21st. We saw, I think, 1/10 of an inch or 2/10 of an inch, and then after that, it really ramped up. We got some storms that were 1/2 inch, maybe a little bit more at some of those mountain locations, particularly in the southwest. And we wound up getting about 4 inches of precipitation in the San Juans there over the course of, I think it was a 2-week period from about July 21st, or excuse me, June 21st to about July 2nd. The northern and eastern half of the state did receive a fair amount of that precipitation, again, as Peter pointed out, but did not receive as much consistent precipitation as the southwest corner of the state. You can see all of the individual sites in the San Juans are almost all entirely that darker blue, greater than 150% of normal precipitation for this 30-day period. You can see only a handful of those sites were below 110% of normal. Whereas in the northern half of the state, you can see there's a number of sites that received below normal precipitation, but there were some that received above normal precipitation as well, and that kind of balances out a little bit above the median for that last 30 days. And then looking for the month to date, or excuse me, looking at the month to date precipitation starting on July 1st through yesterday, and even though this says July 21st, this is in fact yesterday, you can see that those storms really kind of died off a little bit. There was a bit of precipitation that did continue through about July 2nd, and then we've had a few storms that have hit since then, but you can see that it has not been as consistent as it was in those last 1.5 weeks of June. And then close to normal precipitation, or I should say a little bit above normal precipitation for the headwaters of the Colorado, South Platte and North Platte, but not so much, unfortunately, for the combined Yampa White for this last 22 days. All right, looking at the time series graph for the entire state of Colorado, again, you can see precipitation year to date is 101% of normal right here. And here again is some of those, or the majority of those storms that I've been highlighting in the last few minutes from June 20th through about July 2nd. This is where we got that solid bump in precipitation. We were somewhat dry for about a month period prior to that, and then we dried out a little bit after those storms have received a fair amount of precipitation that have tracked pretty close to normal to this point. So, you know, when we really look at it, I think this is a pretty fortunate outcome that we've had. You can see statewide, we were pretty close to normal through the winter, through the early part of May. We did see some spring precip and then dried out again. Again, this is pretty typical for spring and midsummer precipitation. I highlighted, or I'm going to point here to a few basins that kind of show the differences across the state. So in the San Miguel, Dolores, and San Juan basins, you can see that we were running relatively dry over the course of the winter. And then here again, the San Miguel, Dolores, and San Juan actually received a little bit of precipitation, a little bit more precipitation than the north did, especially in the earlier part of June. I think we had some precip on the 10th and the 11th and about the 14th. And then, you know, we didn't have as much rain, and then we got the solid precipitation that we've seen in those maps, those darker blue colors, which really boosted us up. So we were in the lower, the 20 to 40 percentile here, and then we boosted ourselves into the 40 to 60 percentile, almost up to the 50 percentile, but didn't quite get there and have received some precipitation here in these last few days in this combined San Miguel, Dolores, and San Juan basins. Looking at the Gunnison, where precipitation has been pretty good all year, and then again got that solid boost at the latter part of June, and now we're at 108% of normal, as you saw on the map. The Gunnison has been one of the better basins for precipitation in the state. And then the Arkansas has also been doing pretty well. It is now at 111% of normal and boosted us just over the 60th percentile as of late. Okay, looking at soil moisture data, I thought I'd point to this because I know that Peter in the Water and Climate Center, or excuse me, the Climate Center, the Colorado Climate Center, often shows this information. And so while that is model data, this is observed data, and it of course provides input into those model inputs. But here we also have to use this with a bit of a grain of salt because the data set is not fully QC'd and has some information that we need to continue to clean up a little bit. So for example, what we're seeing here in the upper Rio Grande, I'm not exactly sure why it's reading 29%. It is a little bit low. I need to dig into that. But so I would take this one with a grain of salt. The other ones I'm feeling a bit more confident. We are looking at the 20-inch soil moisture sensor at the given sites that we do have these sensors at. Not all of our stations have soil moisture stacks at them, but for the ones that they do, we do have this information here. And for the most part, what we have seen, I would think this data to be true. We know that the Arkansas has been doing pretty well for soil moisture data. And then for precipitation, the Arkansas has done relatively well. The South Platte, the Gunnison, we've seen that those numbers are running relatively high, as is the Colorado River Basin. So showing, and we also have to remember that the 20-inch soil moisture sensor is down a ways. So it can be relatively different than what we're seeing at those 8-inch and the 4-inch sensors as well. It can be a bit drier down there, especially because that's where some of those longer term soil moisture and drought kind of conditions can manifest themselves at that 20-inch level. Moving up a little bit to the 8-inch sensor, again, a sensor that's quite prevalent at the sites that we do have soil moisture sensors at. We can see that this map is yet again a little bit more reflective of what we're seeing in the precipitation maps, the year-to-date precipitation maps. So relatively close. I think that what we have in the data here is pretty consistent and is true. There's just a few sites that we need to continue to clean up and work on. So, okay, reservoir storage. As of June 1, or excuse me, as of July 1, forgive me, statewide reservoir storage is at 95% of median. That's up 1% from 94% on the June 1 value. And so you could see in the San Miguel, Dolores, San Juan combined basins were just below 90% of normal, but in the Arkansas River Basin, we're looking at 123% of normal reservoir storage. Elsewhere in the state, there's a number of basins that are running above normal, 109 in the Upper Colorado, 103 in the combined South Platte reservoirs, 106 in the North Platte Basin, and then 109 in the combined Yampa White basins. Looking at reservoir storage graphically, as opposed to the map, you can see that this year, 2024, is the darker kind of aqua green, and then last year at this point is the more basic green there. And you can compare where the combined reservoirs are. So up here is the state of Colorado, and then the individual basins. You can see that in the Arkansas and the Colorado headwaters, reservoir storage is slightly above where it was at this point last year. And then here's 100% of capacity. This is a graph that's a percent of capacity. So here are the stream flow maps, or excuse me, the stream flow graphs that I was alluding to earlier. And then we actually call these the snow to flow plots. So here you have snowpack, and you can see this year the current line is, or 2024, is the black line, and then you can see the range of historical observances is the colored for snowpack, and then for stream flow is the grayscale values over here. Average or median stream flow is the dotted green line, and 2024 stream flow is the dotted black line. So commenting on Peter and Paul's comment from earlier in his presentation, we do see here that the stream flow runoff was a bit higher than the median. We also need to remember that the median is smooth because of the statistics for all of the previous years that are used in combination. So it is relatively normal to see some of those values go high and then also dip down low. There's a lot more variability in the day-to-day observances of an individual year's stream flow, whereas a median line usually winds up smoothing out as all of the variability is averaged out. But I think what is of interest here is that, you can see that while the average line is up here earlier on in the year, and here we're looking at the Gunnison River near Grand Junction, the snowpack took a while to start melting off, and then the temperatures warmed up and we saw that melt. And then it peaked above the average line, which is somewhat normal, or it is normal, I should say. And then it tends to melt out relatively quickly compared to that average line, because in this case, we actually saw, I think if you'll recall, we saw some above normal temperatures at a few times in the spring, and then we also saw some precipitation that also helped add to it. And then we saw the recession side. And now what we're actually seeing here as of this morning, I did look on the Department of Natural Resources Colorado webpage and saw that the Gunnison River at Grand Junction is currently running, as of yesterday's average flow, 94% of median for yesterday. A little side note here, I'm not sure why this value is reading just a hair above the average line. I'll have to dig into that. Some of these don't look exactly right, but you get the general idea of what happened with stream flow over the course of the runoff season. So going around the state to some of the key stream gauges, I figured I would highlight where stream flows are at this point. So the Rio Grande River at Del Norte did wind up running relatively lower than the median line, not too surprising there. And stream flows currently are 46% of median as of yesterday's average. Arkansas River at Salida, not surprising that we did see some higher peaks because snowpack was pretty high there, and they did receive the precipitation in the mid to late spring. Really provided a decent boost and helped keep these flows higher up here through mid and late June. But now we've seen the recession side kind of kick in as things have dried out, and we see that stream flows are 63% of median as of yesterday. And again, I'm not sure why this is quite so high. I need to figure out what's going on with this data here, but it doesn't quite look like that's a 63% of the median value. South Platte River at South Platte has come up due to the storms that we've seen over the last few days here. As of this morning, the average flow that we saw yesterday was at 75% of the daily median, but looking at a day prior, July 21st, we were at 94% of median. So I updated these graphs yesterday. So maybe there would be a downturn in this line here. I'll have to have a look at that. But that's some of the daily variability that we've been talking about here. But nonetheless, it is below normal on the South Platte. 68% of median on the Colorado at Cameo as of yesterday. Again, we did see some stream flows wind up being a bit higher this year than the median. We'll have to dig into why that's happening. And yeah, Peter, if you want to have Paul contact me, I'd be happy to speak to you and him about it. Okay, and finally, the Yampa River at Maybell. Stream flows are 39% of median here as of yesterday, although the line is indicating it is a little bit closer. We did see some of that variability, and we saw some peaks that were a little bit higher than the median itself. Okay, wrapping up here, I know we're not entirely through the month of July yet, but I did want to draw a quick comparison between our forecasts, which were on the left as of June 1, and the stream flows that we have seen already April 1 through July 30th. I'm sorry, I cut that off here. in this right graphic. But you can see that the streamflow forecast, if you look at the basin as a whole, for example, the San Miguel, Dolores, San Sebastian, Juan basins, our forecast was for about 59% of normal runoff. Again, this is through July 31st, so we still have to wait for July to be fully calculated. But observed through June 30th, we did see about 68% of normal stream flows. The Gunnison was observed at 94% of normal, whereas our forecast was 117. And you can look at the rest of the numbers. Some of these do wind up coming out relatively close so far, such as the Colorado headwaters and the South Platte. And then others are off a little bit, but we do still have to see what comes with July. So, all right, lastly, in summary, statewide snowpack peaked out at about 98% of normal. We had a pretty good snowpack year across much of the state. Currently, as of this morning, precipitation, year-to-date precipitation is 101% of median. We really wound up seeing a boost for our precipitation totals from about June 10th in the southwest portion of the state, but a little bit more about June 21st through July 2nd. Those storms really wound up helping out and providing a much needed boost in many areas, particularly in the southwest. We have seen, well, that's what I was just saying, sorry, the boost in the southwest, it was what we needed because it did dry out this spring in the southwest a good bit. Soil moisture indicates pretty much near normal conditions so far in a number of basins. Statewide reservoir storage is just a little bit below normal at this point, so hopefully we'll see an improvement there. Reservoir snowmelt is pretty much entirely complete at this point. We are on the recession side, and we are seeing a number of those stream flows dipping below, a bit below normal. So we need to keep an eye on that. My guess is that some of the above normal stream flows and the peaks that we saw earlier on may have been driven by warmer than normal conditions, maybe even drier than normal conditions. And now we are seeing the recession side be a little bit more extreme with some of the dryness that we've seen somewhere, but usually we can determine that a little bit better in hindsight when we get further out into the summer. And then at this point, streamflow forecasts are comparing relatively closely with what we've seen, but we need to get the rest of that July data to do the best or the most efficient review of our forecasts. So we'll wait a few more days and have a look at that here in the next few weeks. And that's all that I've got.
Thank you, Brian. If anybody has any questions for Brian, feel free to put them in the chat or come off mute. I have a question for maybe Brian or Peter, kind of based off of what Peter said in the chat. It's interesting that in the South Platte and kind of Northern Front Range, it looks like precipitation is like around normal, yet the drought conditions, specifically the US Drought Monitor, shows that that area is suffering more from drought. So I don't know, maybe Peter has the answer to this. Like what other factors are considered in the US Drought Monitor to show those conditions? Because if precipitation is looking normal, I guess, what are the other factors that would determine?
That's where the boundaries on the NRCS graphics can be a little bit misleading, and you have to keep in mind that they're looking at averages over the high elevation SNOTEL sites, which have done better in recent months. So it almost looked like Brian and I were showing contradictory information, but we're not. And I think if you were to look back at my slides, the high elevations of the South Platte Basin are not shown in at least any worse than D0 on the US Drought Monitor. Whereas the urban corridor and the foothills and the adjacent eastern plains have been much drier than average recently. And the basin boundaries on the NRCS graphics, sometimes it almost looks like they're showing precipitation over those regions too, but they're not. It's just the SNOTELs.
Yep, that's exactly right. Thanks, Peter.
Thanks, Peter, for clarifying that. All right, I think, thanks, Brian, for the presentation, and thanks, Peter, as well. I'd like to open it up now to water providers, water managers, municipalities, to give any updates, on local conditions.
John Orr here, City of Thornton. Our storage is in great shape. We're just a little bit below 95%. Let me switch here. But consumption has been through the roof most of the season since it warmed up. So looking at the latest figures that came out yesterday, our year-to-date consumption, is 21.59% above 2023. And the month-to-date consumption is 33.74% above 2023. So although our storage is in real good shape, we're looking at those consumption figures, numbers, and then also the deteriorating drought conditions in the South Platte Basin and in our watersheds. So we are moving from no drought response to drought watch up here in Thornton. And that drought watch just means that we're trying to get everybody's attention, basically our residents in that, and so that they, they try and water less outdoors or just conserve generally. So that's it for Thornton.
Thank you, John.
Nathan Elder with Denver Water. So similar story to John, our storage is in good shape. We're 96% full. Normal for this time of year is 96% full. So we're right there. Our demands have been slightly above average. So for June, we were 10% above our expected use. And so far through July, we're 6% above our expected use. But it's just the hot temperatures and dry weather.
Yep. Thanks, Nathan.
Yep.
Seems like similar stories in the Front Range area. Any West Slope updates? All right, well, hearing none, I'll just leave it open again one more time if anybody wants to provide an update. All right, well, I think hearing nothing, we can conclude the WCMC meeting for this month. Thanks again to Peter and Brian, and John and Nathan for your participation. So we'll see you next month. The next one is on August 27th. So see you then. Thank you.
All right, see ya.
Thanks.